What are you doing? Where are you going? Hey guys, welcome to the shop. Now, it's going to be a busy week. I've got several things that I want to do. We're going to be back on the cutter grinder because it's a new tool to me. And I want to use it. So we're going to be grinding a slitting saw blade. We're going to grind a face of a tool that we actually kind of messed up last week. And then we're going to be grinding some carbide inserts. My dogs are in the creek. So let's go in the shop and get started. I'll show you that first. It's in the low 90s today, so the dogs they go down here often and get their bellies wet and then go jump on the couch. So they like it. I don't so much. And here's the cutter that we're going to try to grind today. It's just a basic 4-inch slitting saw. And you know, we're starting at the beginning because that's really where our knowledge is. Our knowledge level is anyway. We're definitely a beginner, so that's where we want to start. And something like this should be pretty simple. Now, measuring it's not that simple. Trying to figure out what angles are in this, and I'm going to show you what I used in order to measure the angles on this, the relief angles, what we're going to be grinding. And I'm not for sure it's even correct, but I'll show you anyway. Now, this fixture's pretty neat. It uses just a little spring steel finger to index off the teeth of the cutter. And it's really basic, but it works. And it doesn't require any external indexing unit because it uses the teeth of the blade to index itself, which is pretty neat. We'll get a better look at that in a minute. But let's go over to the bench. I want to show you how I decided what angles I want to grind on this and how I plan to get those ground back on this cutter. Well, all this measuring reliefs on, you know, circular cutters and stuff, that's all foreign to me. So I'm going to show you what I come up with, you know, just, you know, offhand to try to measure the relief angles on this cutter. So I got my center finder here, and I'm lining up my edge of the tooth with the edge of the rule here. I'm going to come in, clamp it on there so I don't have to hold it. Then I'm taking my adjustable protractor and I'm bringing it down and matching it up to the existing relief angle that's on this cutter. Now, I'm just trying to mimic what the original manufacturer had, because these guys, this is made by Cleveland Twist Drill. These guys have been making cutters, you know, probably 4 times as long as I've been alive, so I assume they know what they're doing. And it's probably pretty obvious that I don't. But I just match it up here. This is my magnifier. This is just the lens out of a projector, and it really works well to get you in good and tight so you can see, you know, what's going on. Now, this cutter here looks like it's only got a couple degrees of relief behind the cutting tip. You know, we don't want the cutter rubbing the material. We want just the tip of the tooth to remove a chip of material without the back or all the support that's behind that tooth dragging on the material. So let me bring you in a little closer. I want to see if I can get you a closer shot of what I'm seeing here, and then we'll go to the surface plate and I'll show you how I'm going to get this in the fixture where I can get it ground on the lathe, or on the grinder. Alright, so you can see the setup here. So let me just focus. And I'm just bringing it down. And it's going to be hard for you to tell, but with that magnifier and stuff, I can tell that I'm sitting on the what's left of the existing, you know, or the original relief angle. So that's what I'm going to try to mimic. Let's go over to the surface plate and see if we can't get this set up to where we can actually get that in there. And here's the fixture that I'm going to use, and I had to adapt this to make it work. This is all I had in a box of stuff that come with the grinder. I had no way, you know, it just looked like this without this little extra ring here. This is to adapt it to the 1-inch hole that's in this cutter. And I had to make some sort of holder. So I just spun this out on the lathe and hit it with a mill to get a couple spots on it to where it'll slide over there. And then this is spring-loaded, so it slides over. And it should slide through. Then I rotate it into the locked position and tighten the screw down. So now it spins. Take the finger, put it on here, get it down in one of the, I guess a gullet is what it's called, I think. And now it's rigidly held, or not rigid, but it's held securely, enough for grinding anyway, and then you can just rotate it and back it up against the little finger there. So pretty neat way of indexing. Now, to get this set up to actually get the 2 degrees in the end of this is all off the top of my head. I don't have any literature or anything on setting these up. I'm just winging it here for now until I can, get the proper way. So I'm sure there's a way you could use some sort of formula to come off the center line of this cutter. Get the tip on that center, and then rotate this a specific amount to get that 2 degrees in there. But what I'm doing is the mechanical way, and I believe this is going to work. So I've just got 2 degrees set in my protractor here. Well, I did have it set in there. Yep. And I'm referencing off the square and off the plate, and then I'm going to come in and just line it up by eye. Same way I measured it. I mean, if you can only be as accurate as you can measure. So if I measured it that way, then this should be adequate, I would think, to get it back in. I mean, you could just guess and run this up against the cutting wheel, twerk it just a little, tweak it just a little to where it, looks right, and go with it, and it would probably be just fine. But I want to try to do this at least somewhat correctly, and that's the way I'm doing it. Setting up, this rotates, so I can, keep my finger position locked on one and just slightly adjust this till I get the angle that I want, or my matching angle. Because my wheel is going to be, I'm using a cup wheel, it's going to be 90 degrees to the plate, or to the table, so this should get me close. That's my thoughts anyway. Let's go over to the grinder. Alright, real quick now, I think most of us that get a machine, or any item really, we'll try to find pictures, especially if it's an old item, and try to see what it is we're missing or don't have, or think we need. And I noticed that this machine didn't come with a guard that guards the spindle here off the motor when it's not in use. Now, I think you can put grinding wheels actually on here and use this as a actual grinding spindle. But when it's not in use, it just gets sparks and stuff and debris thrown on it, and can get in the bearings and damage it. So I wanted the protector that comes on this, and let me show you an example of what they look like. Here's one here, and a couple more examples. This one has it, and yeah, just these 3. But it's a protector or a guard, and I wanted one. So I walked outside just a second ago, and I was just walking around the shop, and I seen this in my scrap pile. Now this is just a filter housing, and it was damaged. The screws and stuff was stripped out on it, and it was thrown away. But I noticed that this looked a lot like the piece that I was missing. It was just the wrong size. So I put it on the lathe and turned it out, and it actually doesn't look too bad, and fits pretty good now. So other than, I'm not trying to chrome this thing out, so I'm going to paint this, but works pretty good. I'll have to block this hole with something, but there we go. A trash pile spindle guard. Alright, so we're about ready to cut. Set up here, all I did was mount this fixture to the table and indicate it in on the back. It's got a flat surface on the back here that I can register off of. So I just took an indicator stand, mounted it to the actual spindle, and ran it back and forth, just so my blade is square with the wheel, because the wheel is dressed square to the table. So I also relieved this wheel. Let me bring you in a little closer. I think you can see it best on this outside corner, that little darker ring. This wheel is relieved. 3/4 of the wheel from the inside is relieved, and I've got just a thin little cutting ring on the outside. Alright, so I got my vacuum system going. I've already come in and touched off. So let's get started. Warm the spindle up. And for anybody, this is not a 40V wheel. This blotter, I think that's what they're called, something like that. This paper is off another wheel. This wheel didn't have a paper. It's stamped on the back what it is. So it's a 60J. We're gonna make sure we're up against our finger good. Let the wheel get up to speed. We've already touched off on this one. And we're not taking a real heavy cut. We'll go around this thing twice. Working pretty good. You could sharpen one of these in just a few minutes. Wheel seems to be cutting this pretty good. It's not removing much material. Okay. First time around, man, that was fast. Let's feed in just a little, because I think that we need just a little more. And we'll stop and look at it. Well, I think it turned out okay. Not crazy about the little discoloration on the end. I think I went at it a little too aggressive, but it is definitely sharp. Now, did we degrade those edges? I'm not for sure. I guess the only way to know for sure is to try it, see how it cuts. I mean, the relief angle looks pretty good. Not sure it turned out exactly what we thought it would, but I'm not surprised about that either. So let's put this on an arbor. Let's put it in the mill, and let's cut something with it. Well, unfortunately, I just cut this slot without the camera rolling, so we're gonna cut it again. We got a little run out in this arbor, but the saw seems to be cutting good. We're gonna take a 100,000th depth cut and get you in a little closer. 100 thou. Oil on it. I'm just going to feed across it. It actually cuts really well. But that arbor is not that great. It's a shop-made arbor. I got it in a box of junk when I got that toolbox. It's the only arbor I have, so for a 1-inch slitting saw. I'm pretty pleased with that. I mean, that's cutting really well. teeth though, really, with that run out. But I'm pretty sure that's in the arbor. That setup shouldn't have induced any run out. Nice looking slot too. Now let's go look at it again. Well, I would call that a success. You know, went around this thing and looked at the teeth on it, and they seem just as sharp as before I started. And I didn't baby that. I fed pretty aggressive with it, but it cut really freely. Here's our slot we cut. You know, 2 cuts, 100 thousandths deep each, and just fed it by hand. The only thing I'm not, happy about was a run out in this arbor. But this arbor and this slitting saw were attached to each other in the bottom of that old toolbox. If you go back and watch my toolbox video where I do the tour of it when I first got it, you'll probably see this in the bottom, very bottom of the box. It was attached to this arbor and dull, so I brought it back to life, and I would call that a success. That wheel that we're using, that 60J, even with that dress that we done on it, I'm still not happy with the heat that we generated. If you can see the discoloration on the end of the teeth. It necessarily didn't seem to hurt anything, but I think we can get a freer cut than that. And I need to be mindful of my depth of cut on that grinder. I'm used to running other machines, and I may be a little too aggressive, so not too bad. I'm pretty happy with that. I just need to make a new arbor. So let's go do something else. Well, most of my corn's come up, almost all of it, that we planted. That's pretty rare. Usually you have to go back and transplant a lot, but this year we haven't. Tomatoes are doing pretty good. Peppers and onions. Looks like it's going to be a decent year. Let me take you up and show you the other side of the garden. Now this garden here was planted several weeks before the other one. It was just too wet to get that other in the ground, so it's quite a bit bigger. And a lot of this is my mom and dad's, so it's not really all mine. Beans, peppers, zucchini and squash, and corn. And got some tomatoes on the other end. Just won't stop raining. Okay, last week I said that I couldn't reach the end of this tool, with this fixture. Well, that's not true. Robin Renzetti and both Jim Lichty both said, yes, you can. You just need to articulate your fixture more. And that was true. Sometimes the answer to a problem can be staring you right in the face. With a machine like this, there's a million things you can do, it seems like, to get results that you want. And that was the issue. I just wasn't looking at the fixture good enough. So we can reach the bottom of this tool. We have clearance under the wheel and stuff. But first I have to true this wheel. Dressing and truing are two different things as far as I read. Dressing is when you put a angle or a shape in a wheel, for grinding specific shapes. Truing is when you're just truing it, I guess, with the rotation. I read this and that seems to make sense to me. So we're going to use the word truing. We're going to true this wheel up, then we're going to come in and grind the end of this tool again. And hopefully we'll get good results. We should, because this stone seems to work pretty good. Okay, vacuum system plugging up. VFD on. Spin this wheel up. The wheel rotation should be safe with this left-handed hub that I'm using. Bring this under the wheel and slowly bring it down until we feel a little bit we're slightly away from the center of the wheel, so it can't suck it down under the wheel. We're just going to come down real slow. Just till I hear it and feel it. you're never as close as you seem. There we go, we touched it. And we're just gonna slowly traverse. Until we get a good sound, a good even sound. We're just barely skimming this wheel because it doesn't need much. I think that's it. This wheel is now true, so now we can work on the face of this tool and should get a decent finish. So let me get set up for that and we'll do it. Alright, so we should be, good to go. I'm going to get under this wheel. I'm going to get away from, well, no, I should probably get right under center when I bring down to touch. I'm going to make sure I'm covering the tire wheel with the bottom, or with the face of this tool. That way I don't have any spots sticking higher than the others. That's the thought anyway. This wheel get up to speed. And I slowly come down till I touch. Touch. Down just a couple tenths maybe. Wow, it's already looks good. And I'm just back and forth and feeding across this time. I'm going to try that. Looks good already, to be honest. And I made sure and double checked that everything was tight. I'm not interested in any accidents. And that's it. That was easy. Alright, we just ground the end of that tool around just a little off, and man, that looks good. Not perfect. A little, it's not a Renzetti finish, but it's a good finish. For a tool, we're not looking for perfection. We just want it to work, and that, my friend, would work. So I'm happy with that. At least I know I can get around my, average length 4-inch or 3-inch lengths tool steel with that fixture now. I'm happy with that. Look at that. This heat marks are from the last time I ground it, not from this time. I mean, the tool, when I pulled it out of the fixture, it wasn't even warm, so we just dusted it. Running heavy today. We got a pretty good rain. Well, a couple days went by and I've changed a couple things. I wanted to grind some carbide inserts. I wanted to try to grind some carbide inserts. But I didn't want to deal with this little hose being my only source, of dust evacuation. So I made a scoop. It's just a large, it's 8-inch magnetic base, so I can position it where I want it. And this should do a pretty good job of dust evacuation. When I run it, I get a lot of suction, around this thing. So hopefully this will be adequate for now. And I dressed or trued a diamond wheel. Now, I've heard people say you can't do it. I've heard people say it ain't worth it, but I did it. I did it because I had to. I had nothing to lose. Let me bring you in and show you the wheel that I'm using, and I'll explain to you the way that I dressed it. Alright, here's the little wheel that I'm using. It's just a 4-inch diamond wheel. It's 180 with a 75% concentration. And 180 is, I guess, the granule size or the diamond size, and then 75, I guess, is the concentration of diamonds in this resin bonded area. I don't know a lot about wheels, that's just what I believe. Anyway, this wheel had 7 thousandths of run out in it, which is crazy for a cutter grinder. I mean, it was unusable. And I put it on here, and I used a dial indicator on the wheel, and ran it around. Now, the dial indicator that I used, the tip was already broken off, so I wasn't wearing my dial indicator tip off. Yes, I was, but it was already broken. Anyway, and I went over that. I put my mag chuck on here, and this is steel, which they say you should never use a diamond wheel on steel. This is A2 tool steel. So I seen a video by Solid Rock Machine Works, Solid Rock Machine Shop, where he trued a diamond wheel using this method, running it over a piece of steel. This was a piece that I'd practiced on the shaper and done a diamond pattern on, so it was pretty aggressive. But this thing was way out. I mean, 7 thousandths might as well be a mile, on a wheel like this. But I worked this wheel back and forth extremely slowly, cleaning it with the white diamond wheel stick, every little while. It took probably 3.5 hours to get this wheel to where it runs true, so it's never coming off this arbor. And now I got it to where it's within a few tenths a run out, and I'm happy with that. I'm going to leave it as it is. Diamond wheels are pretty expensive. This wheel happens to be a really cheap wheel, probably, I don't know, less than $10. It's one of those kind of wheels. I don't have $100 to spend on a wheel, so we bought the cheap one. We use it. It right now is fine, but it took a lot of time to get this thing to where it functions reasonably well. It's still not great, but good enough for what I'm doing for now. I can always improve on my equipment later. Right now I want to learn how to use this thing. So that's how I treat the diamond wheel. Let's go get a carbide insert. I've got several for a boring bar that I want to grind. Let's grind them, and then let's try them out. Alright, so we got our slightly wore out insert in the bar, because there's not much better to hold this thing than a pocket that was actually designed for it. And I think it's best that I say, my normal viewers already know this, but I'm always getting new viewers, and this may be the first video of mine that you've seen. I'm not a cutter grinder expert. I'm not a cutter geometry expert. I know the basics like most folks, but that's it. So don't take what I'm doing as the way that it should be done, because it probably is not the way it should be done. But we're learning. I'm trying to familiarize myself with the sounds of this machine, the controls, all the things that you need to do in order to get a successful job. You have to know your machine, you have to know the sounds, and you have to use it. Otherwise, you're not going to get good results because you don't know the machine. That's what we're attempting to do here, and that's really all we're trying to do. It doesn't matter if these inserts turn out good or not. I hope that they do, but if they don't, they were destined for the trash can anyway. So we're going to grind this thing real quick. We're going to take it on the plate and look at it real quick. And then we're going to take it to the lathe and see if we can cut with it. Hopefully it turns out good. Alright, so get our vacuum system going. Safety glasses and variable frequency drive going. Grinder going and get it up to speed. We're going to come down and touch off. off. And now I'm just taking, a few tenths at a time. Just come in a little on the insert. No reason to grind this whole top of this insert when all we're really concerned about is the front cutting edge. Now I need to get some sort of mist coolant, not because this insert gets hot, but because grinding carbide I think would be safer. Even though this really works really well, I think it'd be safer if we maybe, wetted it. The dust from carbide is extremely small. Looks good. Let's look at it and then see how it cuts. Alright, that's what it looks like on the plate. And I wish I could really get a good picture of the finish. It's pretty good. It's got some striations in it, some long striations across the face. And I think I can improve that, by a smoother wheel or my method of cutting this. Probably not the best idea to plunge cut this like I did, cut it all in one pass. Probably best to feed down a little and then feed to the side into the wheel. That's my thoughts, but whatever. I think this will work for now. We got a little bit of positive action, I believe. So let's go take this and put it in the lathe and try to cut some steel with it. Alright, bars in the lathe. Just a piece of 2-inch DOM tubing. So come in and touch off. Take about 20 thousandths, I guess. Get a good start. Too bad so far. Let's do 20 more and add a little oil. See if we get a little better finish. Yeah, that oil helps. Bad. Better than what it cut before, that's for sure. It's leaving a nasty finish with a bad edge on it. Let's try 30. Not too bad. With a little refinement, I think this would work out just fine. You could slightly, alter the geometry to get the cutting action that you want. But let me get you around here, show you this finish. It's actually pretty good. I don't know about you, but I think that's plenty acceptable. And our little insert done its job. So, no real build up or anything. It's pretty good. I mean, I couldn't ask, I don't think, for that to go too much better. I could work on the finish, and I plan to. I need to get some better diamond wheels, some with a finer grain size and just better wheels. Those cheap wheels are, well, they leave a lot to be desired, let's just say that. And the method that I had to go through to true it was probably not the best thing to do to a wheel like that, but it seemed to work. It got it running true. It got it to where we can use it, and that's all I'm trying to do right now is, like I said, get the feel of the machine. My buddy Matt sent me a bunch of horizontal milling cutters, and he looks like he picked through them to get some with different shapes and whatnot, some with helical teeth, some with staggered teeth like this one, side cutting edges. I mean, that's a complex cutter, and a cutter like this would be really expensive, so you definitely wouldn't throw it away. If it got a little burn up on the ends, you would regrind it. That was a common practice, and it still is some places. So learning to grind a cutter like this successfully would be pretty tough, but I'm up for it. I think we can do it. I don't have a horizontal mill to try these out, but Brian Block does. He could try some if he wanted to, maybe. And who knows, maybe in the future we'll get one. It's definitely on my list, but those things are big and heavy, and I don't want a small one, so we'll have to find one, I guess. I've been studying cutter geometry and cutter grinding, and with the little bit of literature that I have and that I have access to, it's tough. There's a lot to learn, especially when you're not a cutter expert. But you got to start somewhere, and that's what we're doing. So I'm pretty excited about it, to be honest. I really like that machine. I think we're going to be able to do some really cool things with it. Matt sent me some that have radius edges on them. Now, I don't have a radius grinding attachment for that machine, but I'll have to get one. I'll have to find one. They're fairly a complex unit. I guess next we'll probably try to sharpen some flutes on some end mills. Maybe not an end mill like that is angled. Maybe just a straight fluted end mill. I got the end mill grinding attachment that I've yet to even try, so maybe next we'll try that. Who knows? I think, like I said, this turned out pretty good. If you were burning up several inserts, you would burn up several, or just get them to where the edges are degraded and get a batch of them, and leave the bar in the holder and just batch grind them. I think Stefan Gottswinter does that, and Robin Renzetti also, I believe, touches up his inserts when he needs to. So it's done. People do it. It's successfully done, and all we have to do is refine it. So I'm pretty happy with that. So thanks for watching, guys. I really appreciate it. If you haven't, make sure to subscribe to the channel by clicking on my little guy up here and hit the bell for notifications. And as always, I'll see you next time.